dear students, hope you are all fine and I hope that you have watched all the previous videos of wave optics, and we have discussed about reflection, refraction, how Huygens explained the reflection and refraction, then what about the interference, okay, another one property of light when it is behaving like a wave, that is interference. So today we are going to discuss about the another one phenomena of light, that is diffraction, okay, diffraction. So for that, you let us consider, before telling the definition, let me explain. So here there is a source of light, okay. So light, it is in the form of wave, and this is the direction of propagation of the wave, okay. So when the light is passing here, okay, so you can see here the screen from this point to this point, the screen will be brighter, okay. When you see, take a screen and you pass a light source, the screen will be brighter here. But here you consider there is an obstruction. Something is obstructing it. Obstructing na thadukkudu. Okay, something, a cardboard or something is obstructing it. The same source of light is coming here, but it cannot pass over here as it is passing here. Okay. Here we can see the shadow. Okay, this is the shadowed region. Or madri dark ah theriyum. Okay. We call it as shadowed region. Okay, here there is a shadowed region. So this is what happening. Light is coming when it is a wave. Okay, here it is brighter, but here there is an obstruction. Because of that obstruction, here there is a shadowed region. Okay, so shadowed now, konja dark ah irukku. Okay, shadowed region because there is an obstruction. But geometrically, when you see, the light should be brighter from this point to this point. This is light direct. So the light should be brighter from this point to this point, and from this point to this point it should be darker. But actually what is happening means, when we do it practically, we can see that the light will be brighter up to this point. Okay. Similarly, if there is an obstruction, it will be also brighter up to this point. So the light will be brighter up to this point to this point. Idu varaikum brighter irukku. Purida? The light will not be inga varaikum na brighter irukku appdi kedaiyadhu. When you see, when you observe it, you can see the light will be brighter from this point to this point. Okay, that is, it is bending towards the shadowed region. Okay, when there is an obstacle, what is happening? The light is bending towards the shadowed region. Adoda sharp edge la irundhu it is bending, in the edge la patta odane adu enna it is bending towards the shadowed region. So a phenomena arises, right? Whenever we observe something new, we will call it as a phenomena. That phenomena of light wave, we are calling it as diffraction. Okay, so what is meant by diffraction? Bending of the light wave at the sharp edges towards the shadowed region. Or light wave வந்து bend பண்ணி அப்படியே shadow region towards அது போகுது அப்படின்னா, that we are calling it as, that phenomena we are calling it as diffraction of light. So what is diffraction? Bending of waves around sharp edges into the geometrically shadowed region. Okay, bending of this light wave around the sharp edges to the geometrically shadowed region. The bending of light, it have a rule, okay. It will not bend towards the brighter region. It will always bend towards the shadowed region. Okay. So this is similar to what is happening. Why it is, so it is opposing the ray optics, right? In ray optics, we studied the light will travel in a straight line. So if it is traveling in a straight line, whether we can see this area as brighter? No. So by this we can clearly what Young's told, what Huygens told is also right. Okay, avanga sonnadhu ipa correct ah irukku illaya. So this is similar to you fill a room full of water, okay, and suddenly if you open the door, you can see the water is flowing into the next room. Whether it flows in a straight line? No. It will flow as a wave ஆதான் போகும். Yeah, similar to that, this also, light is also having a wave nature. Okay, by this we can understand it is having a wave nature, and it is because of that nature it is spreading like this. Okay.
So based on the wavefront we are using, okay, spherical or cylindrical or plane wavefront, based on the wavefront, the diffraction is divided into two, that is Fraunhofer diffraction and Fresnel diffraction. Okay, so in Fraunhofer diffraction, okay, So in first, let us see about what is Fresnel and what is the difference between Fresnel and Fraunhofer diffraction. So in Fresnel diffraction, we can see this the spherical or cylindrical wavefront. Okay, the wavefront is, if the wavefront is spherical, point source length varado, illa cylindrical wavefront na, we know that, right? Cylindrical wavefront means, you know, அதாவது அந்த மாதிரி, ஓகே, சோர்ஸ்லேருந்து வரக்கூடிய லைன் சோர்ஸ், ஓகே, லைன் சோர்ஸ், பாயிண்ட் சோர்ஸ் இல்லை லைன் சோர்ஸ்லேருந்து வரக்கூடிய அந்த வேவ் ஃப்ரண்ட்டுக்கு நம்ம யூஸ் பண்ணுற டைஃப்ராக்ஷன் ஃப்ரெனல் டைஃப்ராக்ஷன். ஓகே, இஃப் த வேவ் ஃப்ரண்ட் இஸ் ஃப்ரம் இன்ஃபைனட் சோர்ஸ், அது வந்து வர்றது இன்ஃபைனட் சோர்ஸாக இருந்துச்சு அப்படின்னா, ரொம்ப தூரத்தில், ஃபார் எக்ஸாம்பிள் சன்லைட் எடுத்து நம்ம ஒரு டைஃப்ராக்ஷன் எக்ஸ்பெரிமெண்ட் பண்ணுறோம் அப்படின்னா, இட் இஸ் ஃப்ரம் இன்ஃபைனட் சோர்ஸ். ஃபார் தேட் we will be using Fraunhofer diffraction. Okay, then the second point is light waves is a form of finite distance, as I told, from a source at a finite distance. So this we have studied already, right? Spherical and cylindrical wavefront means the source is from finite distance, either it is from point source or from line source. But plane wavefront comes from infinite source. Okay, so the source at infinity, here the source at a finite distance, here source at infinity. The next one is, for laboratory conditions, convex lens need not be used. Not using the convex lens, ரொம்ப பக்கத்துலேருந்து தானே வருது, அதனால் நம்ம வந்து we are not using the convex lens, அதை கன்வெர்ஜ் பண்ணி எடுக்கிறதுக்காக we are not using the convex lens. But here in laboratory conditions, when doing some experiments, we will be using convex lens. Then this Fresnel diffraction, it is very difficult to observe it and to analyze it. Okay, so to find out the brightness or darkness, everything, it is very difficult. But here Fraunhofer diffraction, it is very easy to analyze it. So for our analysis purposes, we will be using this Fraunhofer diffraction. Hope you could get an idea. This is one of the important 3-mark question, the difference between Fresnel and Fraunhofer diffraction. Okay, so hope you got an idea about these two, and thank you for watching.